Please pause the video and take a moment to read this important safety message. Hey, welcome back everybody. Part 9 here in the single-ended KT88 amplifier build. This will be the last video I'll make on actually the construction or build of this amplifier. And also in this video we're going to do some bench testing of it and just let you see how this amp's performing. I will tell you, I have been running this amp for about 3 weeks now, 2.5 weeks. Exclusively in the listening room here, and it has been pretty amazing, to be honest. I had a good friend of mine come over last Sunday, Jeremiah, and we sat and listened to it through probably 50 or so different songs of different genres, makeup, and and mixture there, and the thing just performs extremely well across the board. We did a bunch of tube rolling, and I'll get into more of that in one of the upcoming videos, but found a tube complement in this that really sounds good. And what I was wanting to focus on today, if you'll notice, we're running about 230 volts or so, and right now what I'm connected is just to ground, and over here to the plates of the 6M1P tube. And everything, you know, while this is within the specs for this tube, I went back through and read the whole 20-some page forum that Kegger and these other guys had done on this design and build of this amp. And these guys spent a year or more tweaking on this design. And one of the things I found was, while I'm running the B plus to the output tubes pretty hot right now, I've got it at about 450 volts, which I'm actually really happy with. It sounded really good on the KT88s. You could run EL34s at that voltage. You could also run 6L6, the GC variants at the high voltage. If you wanted to roll some other tubes into this amplifier, you might have to get the B plus down a little bit to do so, to not have to worry about burning up the tubes. But anyway, I like it where it's at because it sounds amazing, and it's a pretty, you know, putting out a pretty decent wattage for these KT88s. But the downside of that is, in the current design, it's coming with a little bit high voltage here on this 6M1P. So everything I read in that forum basically said I need to get this 6M1P's plate voltage down around the 150, 160 volts range. That's where they've proven out that it would sound the best at. So I haven't done that yet. I was about to do that here today, and I thought I'd start making the video on it. So what we're going to do is, if you remember, these resistors right here are actually the voltage dropping resistors, which, if you look at the schematics, coming off the B plus here, you come through this 4.7, and then you go across this last filter capacitor to then get into the plate load resistor here of this tube. So what we're going to do is we're going to increase this 4.7 ohm resistor to the point that we get the plate voltage down here to around 150, 160 volts. And without going back and spending a lot of time doing the math on all this, an easy way to go about that, and the way I'm going to do it from a practical standpoint, is I'm just going to take one of these sides out of the circuit here, and I'm just going to use like a substitution box, or in this case I've got a bunch of Dale resistors in little bags, and I'm just going to start with a 7.5K and put it here and see what voltage it gets me. And if that doesn't work, I'll substitute in a different one until I find the value that gets me what I need. A little bit of a trial and error method, but it won't take 10 minutes to do so. I'll just use some alligator clips and go through it until we find the right value. So let me do that, and I'll come back in and show you what we found. Okay, I don't often go handheld shaky cam, but I'm going to here for a minute. So I've just been trying in different resistors here, and I've got them jumpered over here via a set of just alligator clip wires. And if you notice, I'm running at 157 volts now on the plates of the tubes. And what I've done now is I've also got this meter, which is showing 234 volts, measuring across this resistor right now. So I'm determining how much voltage I'm dropping. So I'm dropping 235 volts across this. Turns out that it's a 150k ohm resistor that got us to the 158 volts. So if you kind of do the math on that, V square divided by R, so 235 squared divided by 150k, you come up with about 0.368 watts. So I just wanted to make sure a 1 watt resistor would be fine in this scenario, and it will be. So that's what we're going to do. We're going to drop in 150k on each side right there, and it'll get our plate voltage down to the between that 150 and 160. By the way, I've been listening to it, and it sounds amazing here. It sounded amazing before, but I think it'll help prolong the life of the tube. It'll also help out a lot if you're trying to swap in and out a 6DJ8 into this spot. It'll be much more accommodating with this voltage here. Well, I've got the amp now running at the 160 volts on that tube. However, my percent distortion has gone up. I was running down around 0.3% distortion across the board. Now I'm running up right around 1% across the board. I think I'm going to have to play around with various voltages here and see how it affects my distortion on this input tube. This is interesting. I've now increased the voltage back up, and as you can see, my frequency, THD versus frequency, is not as linear now, which is no big deal. From 100 hertz here up to 20k, it's way below 1%. Matter of fact, up around 1k, I'm at 1.136% distortion. So I actually think this amp may like a little bit in between. I may kind of pause this video series here, and not that you guys would know it, but do some listening tests over the next few days and then come back to you once I've figured out an optimal voltage from a listening standpoint for my ears. Oh, guys, I've been playing around for a few days now, and I'm torn. Let me tell you what I'm finding here, okay? Remember how I had the original design specs by Kegger and all these guys had kind of stacked this thing up here with, you could run an ECC85 with a 6AQ8. Well, here's the deal with that tube. And by the way, that's what I've got in here right now. When I told you I found a tube that I thought sounded the best, it's actually this very top one. But it'll handle 330 volts on the plate, okay? 6M1P, 250 volts on the plate. The problem is when you get down to the 6DJ8, you're at around 130, 140 volts maximum plate voltage. So now I understand why the statements were kind of saying, hey, get this voltage down to 150 volts on the plate of this driver tube, because then it opened up all these other possibilities. However, what I'm finding is this amp sounds the best with either a 6AQ8 in it or a 6M1P with the voltage up around 220 volts or so sitting here on this driver tube. So, I said I was going to build this thing originally kind of like what was, the schematics that were out there, but I think I'm going to leave mine with the 4.7Ks in here and actually run this thing a little hotter with the 6AQ8 tube or ECC85, which is perfectly fine, or I can put in 6M1Ps. It just limits my ability to run the 6DJ8 tube in this amplifier. So it's a little bit of a trade-off. I'm getting much better distortion figures at the higher voltages. If I try to run the ECC85 or 6M1P down at around 150 volts, it brings my distortion figures up from like 0.3%, well, 0.1 to 0.3%, up to around 1% or so. Not that that's the end of the world. 1% is not horrible, but it's a compromise. So I think I'm going to run with the higher voltage here, up around 220, 230 volts. And just limit myself so I don't put 6DJ8 tubes into this amplifier. You, on the other hand, if you wanted to be able to swap all these tubes in and out, you could increase this resistor right here up to 150K. It will get you 160 volts on the plates. Then you could run about all these tubes you wanted to here, with some little higher distortion signals. So I like the way I've been listening to the amp for the last few weeks. It sounds friggin' amazing, to be honest. And so that's what I'm going to do. I'm going to leave the other option up to you, and you can use this video as your document on how to go about changing that. It's as simple as swapping these two resistors out right here with 150k ohm. You could run, I've been playing around, you could run say 68k ohms and end up around 200 volts. You could run you can keep playing around anywhere in between there if you wanted to, but that's kind of what I found. So I'm going to stick with the original schematic the way it's drawn right here. It just I think you have to take off the 6DJ8. I actually listened to it with the 220 some volts with the 6DJ8. It doesn't sound bad, and it actually works. It doesn't sound as good, and on top of that, the life of the tube won't be as long there. So that's what all this is about. It's about compromises and trade-offs, and do you want this or do you want that? It's no different than the linear or ultralinear mode on this unit. Which do you think sounds better? That's a very subjective question. I've found the ultralinear on this is flat out amazing, to be honest. So, all right, I'm gonna wrap this part up, and I'll show you some bench testing real quick. Okay, you guys will probably be happy to see that I've got the Analog Discovery 2 running with the These Stuff Made's audio analyzer suite, and which that's good news because I can now come back around and make continue my video series with you guys on this. So at any rate, let's run this thing. Let's sweep it. I've got it set to channel 1, 20 hertz to 20 kilohertz. And it's running through. Somebody asked me the other day on one of my videos, hey, I hear a noise in the background. I've got this running into a dummy load right now, but you do kind of hear the noise in the background of this this thing, even with the dummy load kind of resonating through the Analog Discovery 2 here at the higher frequencies. So it's not coming through the speaker. But anyway, let's take a look at this. So all the way down here at 30 hertz, that's when we start to cross over below, right around 30 to 40 hertz. We drop below 1% distortion. And this unit stays below 1% distortion all the way up to the 20 kilohertz range. Down here at 100 hertz, we're at 0.429% distortion. Here at a kilohertz, we're at 0.120. Through a lot of the audible range that you would, vocals and whatnot, we're 0.143, 0.12, just really good distortion figures on this thing all the way across here. We can also run a frequency response, and it'll take it a minute to sweep as well. And keep in mind, you measure the bandwidth of an amplifier by measuring from 3 dB down, right? The 3 dB down points from 0. Would be considered the bandwidth of an amplifier, okay? Well, let me show you here. All right. At no point, even at 0, the lowest frequency here at 10 hertz, we're only down 1 dB. So this thing, from the time you get up to about 20 hertz here, all the way through up here, till you get to about here 12 kilohertz or so. This thing is just about flat. Then it starts to dip off a little bit, but you don't get down even, you're up here at 20 kilohertz before you're even down a half a dB. And so that's more than I can hear, I can promise you that. My hearing drops out somewhere here around 18 kilohertz. And at that point, you can see we're down 0.7 dB at that point. So the bandwidth on this thing's amazing. It doesn't actually hit the 3 dB point till you get up to 42 kilohertz, which none of us can hear, by the way. Maybe your dogs running around. But my point is pretty darn flat, amazing specs on this thing. I've not reconfigured this the setup to be able to run the IMD, but you can even tell back here, the spectrum analyzer here, things are pretty quiet. I think I will flip it over to the bench and just check it out on spectrum analyzer over there as well. Okay, at this point we've got the amp running. As you can see here, I've got it, sine wave coming out of it is just about as beautiful as any sine wave I've ever seen. Over here on the HP8903, I'm running at basically a kilohertz, and you can see here 0.17% distortion. By the way, I've done some comparisons between the 8903 and the audio analyzer suite, and it's pretty darn good. It's not perfect, and I'm not saying this is either, but it's good enough for what we've got going on here. And let me turn on my spectrum analyzer. I mean, you can see this. There's not even a blimp on here. I mean, I have to totally overdrive this thing completely to even start to get something here. But this is at the 257 millivolts. Compared to this is so far off scale, you can't even read it. But if you bring this, if you bring this within scale here, which is up around 2 volts, there's not even a blip over here of harmonics, so things looking beautiful. Okay, now I've moved up to this is just a function generator I use with a built-in frequency counter. I picked up for $30 at a Hamfest, by the way. It's an amazing unit. At any rate, let's get over here onto our oscilloscope a little closer here and zoom in a little bit. All right, that's our sine wave. I'm going to flip the function generator over there to square wave. I want you to look at that. I'm seeing no overshoot, no ringing. I'm seeing steep walls on all sides, and that's at a kilohertz right here. As I change this downward, you see that's on down. Oh, that's around 100 hertz. You start to see a little bit of now we're going to sweep it on up. 3, 4, 5, 6, 7, 8. But you get the idea. This thing stays. There we go. It's beautiful. I don't even know how to describe it. This just isn't the stuff you get after building an amp right out of the box. I mean, right off the schematic or whatnot. So I can't say enough good things about this amplifier right now, and how it's performing and how it sounds. So I'm just recommending for everybody, if you got $700 or $800 and you want to throw it into an amp, and you want to have a lot of fun along the way doing it, this might just be the one. So let me take you back over just for one more minute to the desktop, and then we'll wrap this video up. Alright, so some other things I've been working on relating to this amp in the meantime. And you might not believe it, but there's a lot of work that goes into building a bomb like this, and finding part numbers and updating it and tweaking it as you've built the amp or whatnot. But anyway, I've been updating this. I'm up to version 3 now. And I do not have this version posted online. As a matter of fact, I took down the pre-build versions that I had posted up. Just, by the way, if you guys went and ordered a bunch of parts, I warned you that there was a pre-build list and that it could change. Not a lot changed, but a little bit did. A few things here and there. You'll end up ordering maybe $20 or $30 worth of stuff again, and maybe throwing away a few parts if you did order the original one. But so a couple things I've done here is I've tried to add in links more so where I can, either to the actual parts or whatnot. I've gone through and I've double checked a lot of part numbers. As I've tweaked the amp, I've tweaked part numbers on here, and then ultimately, I've kind of rounded it out. Looks like we're up to about $744 on the amp right now. That's without shipping of any type. And then I've also been working on this alternative options set down here, and I'll get into more of some of this when I get into the tweaks. But one thing people have been asking me about, I've gotten quite a few posts, is what would be the European power transformer for this, and it's this XPWR 144, and so I've got it listed on here. I will be putting this up along with full-size schematics. I had been posting them on my website, and it was shrinking them down, and people were having a hard time reading it. So I'm going to put all this stuff up in a Google Drive, and then just put a link on my website to this Google Drive. And so you'll be able to get to the full-blown spreadsheet. You'll be able to get to full schematics, as well as large versions of those. I've also been updating the schematics along the way. The other thing that I've got going on, I'm going to make 2 more videos beyond this. The next one you will see will be the walkthrough of this amplifier, a detailed, as far as I think my audience can handle, walkthrough of each part and component and what its purpose is, basically, okay? And we're just going to do that one into the other of both the amplifier and the power supply schematic. Then beyond that, the next video you will see, which I think will be the last in this whole series, will be one entitled Tweaks, okay? And I've made a spreadsheet of both what each component does with a detailed description, as well as the tweaks and what each of those tweaks, the description of what they may do. So so I'll be putting all this up over the weekend, hopefully here into the Google Drive, and hopefully I'm going to wrap this whole series up this weekend is my goal. If not, maybe right after Christmas next week. I'm off all week next week, so stay tuned. Hope to crank out a lot of content video-wise. That is my goal anyway. So I'm having a lot of fun. This amp is nothing short of amazing, and I've got a couple other listeners that have been over here now to listen to it, and I think they would attest to the same thing. You know, I'm saying, if you've been looking for something to build, this might be the one. And I think I've gone to the level of detail throughout this thing, and we'll through the next 2 videos that would walk you right through building this thing and understanding it a little bit with no trouble. So thanks for watching, everybody. I know it's been a long, drawn out kind of adventure here together, but I promise you we're coming to the end soon.